Hello everyone, in this video we are going to solve question number 4 of K 2018 paper physics. So the question is, in spherical polar coordinate system, the unit vector theta cap at the value 10, pi by 4 and pi by 2. So your spherical polar coordinate system has three independent basis vectors r theta phi, and this is the value of r theta and phi. So you have to find out the value of this theta cap at this coordinate r theta phi. Okay, so we all know that in Cartesian system, any vector r cap can be resolved into three components: rx I cap plus ry j cap plus rz k cap, where I, j, k cap are nothing but the basis vectors or three independent directions or three independent directions along which we can resolve any vector in 3D Cartesian system. Similarly, in spherical polar coordinate system, we do certain transformation from Cartesian to spherical polar coordinate system, where the independent vectors or your coordinate system is defined by r, theta and phi. Okay, so to do this transformation, suppose you have any vector, you have this Cartesian 3D Cartesian system x, y, z, and you have any vector which is lying in this plane, three-dimensional plane, and it is defined by this position vector r. Then this angle is theta, and the projection of this p in this x y plane is this, and the angle made by this projection with the x-axis is phi. Therefore, you can write z is equal to r time cos theta, x is equal to x mean r times sin theta, this is r sin theta, times cos phi, r sin theta cos phi, and similarly y can be written as r sin theta sin phi. So we just did these transformations and we just put in back into this original equation, and finally what we get is our line element in the spherical polar coordinate system. So the line element is nothing but dr r cap after doing all the transformation, r d theta theta cap plus r sin theta d phi phi cap. So this is a line element in a spherical polar coordinate system. So in the question they've asked what is value of theta cap. So theta cap is nothing but 1 by r partial derivative of, okay, so you need to find this 1 by r times del of L by del theta. Now one of the important thing is this, that suppose this is equation 1 and this is set of equation 2. Therefore, when you just substitute the value of these two back into 1, so where your what you will get is r cap is equal to, in place of rx we'll put r sin theta cos phi, r sin theta cos phi I cap, plus in place of y you will put r sin theta sin phi j cap, plus in place of z you will write rz is nothing r cos theta k cap. Now when you just now you have to find what del L by del theta. So okay, so one more thing, this line element instead of L for the convenience of the convention use, you can just write it as suppose dr only. Okay, so it has three independent components. So okay, so yeah, dr. So now to find del r by del theta, so that is easy. You just r cos theta cos phi I cap plus r cos theta sin phi j cap minus of r sin theta k cap. Now 1 by r times del r by del theta is what? This is your theta cap, which is what you want to find. This is theta cap, and this is what you just take out r and take here. So what you'll get is cos theta cos phi I cap plus cos theta sin phi j cap minus sin theta k cap. So you have to find theta cap at the value 10, pi by 4, pi by 2. So you just put the value of theta and phi into this equation. So you will get cos of pi by 4 sine of pi by 2 I cap plus cos of pi by 4. Sorry, this is cos of pi by 2 plus sine of pi by 2 j cap minus sine pi by 4 k cap. This is actually cos. Okay, now cos 90 is, you all know, is 0, so this term will vanish. What will left? Cos pi by 4 is 1 by root 2, sine pi by 2 is 1, so 1 by root 2 j cap minus 1 by root 2 k cap. So 1 by root 2 j cap minus k cap. So this is the answer. So out of these 4 options, your D option is correct. So this is how you find the value of theta cap. Similarly, you can also find the value of r cap by just putting del r by del r, and similarly you can find phi cap also as del phi by del r by del phi. So this is how you solve this kind of question. Thank you for watching this video.